The past decade has witnessed remarkable advances in technology, transforming the way we live and interact with the world around us. Many advancements were made to develop increasingly powerful hardware and high-speed internet connectivity, from smartphones to interactive digital assistants, which have become extremely popular and help enable us to access information, communicate, and perform a wide range of tasks on the go. The increase in demand of electric vehicles has been one of the highlights of the past decade, with the simultaneous improvement of AI and machine learning. The rise of cloud computing also has been a game changer. Cloud technology has made it possible to store and access data remotely, eliminating the need for extensive local storage. It has opened up new possibilities for collaboration, data sharing, and scalability, benefiting individuals and businesses alike. Furthermore, the Internet of Things, IoT, has gained immense popularity in the past decade because of the many applications it offers. In this video, you will see the steps of our IoT-based graduation project for the year 2023 and 2024 under the topic of supply management of electric vehicles. And to start, let's take it back to the problems that influenced us with the project's idea.
I was very struck by what Inga Anderson said, the Executive Director of the UN Environment Programme. She said, scientists have been telling us for over 3 decades of the dangers of allowing the planet to warm. The world listened but did not hear. And I wondered, do you think government and people will... It's a difference, isn't it, between taking any notice of this and doing something about it? It is unequivocal that human activities are responsible for climate change. That's the finding of a new study by the UN's Intergovernmental Panel on Climate Change. It's the most up-to-date assessment of how global warming will change the world in the coming decades. Environmental experts have called it a massive wake-up call to governments to cut emissions.
Well, over the past few weeks, we've been reporting extensively on the heat waves that have hit large areas of Europe, the United States, and parts of Asia. Well, now, leading scientists have told the BBC they're concerned by the recent run of new climate records being set, saying the speed and timing of them is unprecedented. Some fear we're already witnessing worst-case scenarios.
The fact that we're seeing the world warming because of greenhouse gases is not unexpected, but seeing some of these records being broken, these marine heat waves in the North Atlantic, the severe decrease in Antarctic sea ice was not expected, and it's something that we're going to have to work to try and understand.
Australia's EV charging network will face a test this weekend as holiday traffic fills highways. EV sales have tripled this year, meaning more electric cars will need charging at various stations. Last year, frustrated EV drivers criticised the wait time of up to 90 minutes for vehicle charging stations to be free for use. However, the federal government says there has been a 70% increase in public EV charging locations since then.
As we've seen the problems, it was time to look for a solution. To solve the problem of the difficulty of charging an electric vehicle for users, especially in times of traffic or high demand, we designed a model of 2 stations and a robot car. With the help of Arduino IDE coding and Flutter applications, we were able to integrate an IoT system of both working software and hardware. Each station is designed to have a capacity of 2 level 3 chargers, and the robot car is Bluetooth controlled, which eases its use in test cases. It's an IoT system of both hardware and software, and the first thing we're gonna look at is the hardware. This is a look at the hardware and the wiring for Station A. Station A is powered by a Wi-Fi module, the ESP8266. This Wi-Fi module is considered to be the core of the station, and it's powered by using a micro USB and a power adapter. For the station to sense incoming objects, we had many options, but actually chose to go with ultrasonic sensors for their reliability. The sensors are placed as follows. There is a sensor at the front to identify when a car enters the station. There is also a sensor at the end to subtract from the number of total cars when a car leaves the station. Lastly, there are two sensors playing the role of a station charger. As long as a car is charging, no other car can take its place, eliminating potential errors. The wiring is facilitated using breadboards and jumper wires, with the sensors connected to the general purpose input-output pins. Now let's have a look at the wiring of the robot car. The robot car's main components are the microcontroller, the Arduino Uno, the ESP8266 Wi-Fi module, the dual edge bridge, and the 4 DC motors, each connected to a wheel, and finally the Bluetooth module. With the help of an already in use application called Bluetooth RC Car, the robot car's Bluetooth module connects to the app, and the user is able to control the movement of the car. The motors are then connected to the motor driver so that the microcontroller can control their speed and direction. And now with the coding. All of the coding of this model, especially the hardware, is achieved using Arduino IDE. The open source Arduino software makes it easy to write code and upload it to the board. For the car, the code contains if conditions for each case the car would move: forwards, backwards, left or right. The loop function awaits the commands coming from the Bluetooth application and moves accordingly. The pins of the motor driver and the Bluetooth module are initialized. Libraries such as ESP8266, Wi-Fi, and Wi-Fi Client Secure are used.
Google Cloud has played a huge role in the project. With APIs provided such as Maps API and Sheets API, we were able to integrate our Arduino code with Google Sheets. This battery sheet shows the reading number, the date and time of the reading, and the red battery level. The reading is updated each 10 seconds. This is the station's data sheet. It also shows the reading number and its date and time. It shows the status for chargers 1 and 2 if they are charging or not, and the number of cars in station, and the total energy consumption by these cars. This is the Google Sheet view for a test case of one car entering the station. We see that the F and E columns change. Column E shows the total number of cars in a station, and column F shows the total consumption of the cars in a station. The car remains in waiting mode until columns D or G change from 0 to 1. If either of them change, it means that the car reached one of the two chargers. After the car finishes charging, column G returns back to reading 0. The charger sensor is no longer reading a car. Lastly, when the car leaves the station, all the readings return to 0. The station is now empty. So far, we have seen the hardware and its coding, but the most important part, the final product, is the user interface. Flutter is an open source UI software development kit created by Google. It is used to develop cross-platform applications from a single code base for any web browser, Android, iOS, Linux, macOS, and Windows systems. This is the application that we built.
e-Voyage. The first screen shows the driver's car battery level, read from the Google Sheet. The second page shows a list of the available stations. This project only included two, Station A and Station B. When the user clicks on one station, he is directed to Google Maps to start the trip to his destination. Third page is the charging page. The user opens to a comparison between the two stations with sliding cards to the left and right. It shows important data such as the distance from the station, the battery reliability, the number of cars waiting and the number of cars charging, and the waiting time in each station. This helps the driver detect nearby stations and find the best option for him. The app recommends a station that most likely has the least waiting time, and the button directs the user to Google Maps to start his trip. If the driver has another point of view, he can always return to the Maps page and choose a station to his preference. The last page is the user's account page, which requires the user to sign up with his username, email, vehicle model, and password. Now it's time to test the integration of all these elements together. Test case 1 is exactly the same as the Google Sheets case. One car enters the station and is in waiting mode. Moves up to the charger and the app adds it to the number of cars charging. As it leaves the station, cars waiting and cars charging are changed to 0. Test case 2 is a case between Station A and Station B, checking if the app will respond correctly to the sensor's output. Both stations have 2 cars charging, but Station A has 3 cars waiting and Station B has only 1 car waiting. Test case 3. This case sees both stations at full capacity. Station A has only 1 car waiting this time, while Station B has 5 cars waiting. The following message is from both teams working on this project.